Okay. Hello everyone, I'm Jun TAO, a PhD student from Ohio University. Dr. TAO was absent due to visa issues, so I'm very pleasure to give you this presentation on his behalf. Our topic is about regional augmentation for real-time positioning service. We all know high accuracy, especially BP services, have made a significant progress nowadays. Many operations have claimed to provide BP services without convergence times. However, most instantaneous operations rely on commercial augmentation service. In parallel, targeted efforts to provide positioning services are also fully underway. As ordinary users, we have BDS-3 from BDS-3 or Galileo hubs or IGS, etc. All of them are free of charge for decimeter level BP at present. Some assessment of public positioning services are displayed here. When we leave ambiguities afloat, standalone BP convergence is far from articulate performance, with long time lost for initializations. Assuredly, adding NS fields constraints to CLAS can improve the BP performance, but it highly relies on the dense network to provide precise NS field. Also, the NS field sometimes may exhibit irregular variations. Based on the current situations, we'll certainly wonder, can we implement instantaneous centimeter level BP with sparse network? Basically, let's check our demand. We need low-cost infrastructure to serve as many available end users as possible. Most importantly, the wait time should be as seamless as possible. Besides, the convenience of corrections transmission and the additional bias should be treated specially. Based on the above issues, we provided our proposed solutions. We demonstrate a real-time positioning service in China and only utilizing the ambiguity fixed without enhancement field to realize a unified multi-frequency OSB generator. Next, we will describe in detail how to implement our service. It's widely known that multi-frequency can form precise geometry to optimize the model strings. But if we use uncombined model like we usually do in BP for the multi-frequency clock estimation, it will take up a huge compute burden. Here, we introduce the phase triple frequency combinations. If we let the coefficients satisfy these three conditions, we would obtain the phase one lane measurement, which is so-called the PWL in our research. So we can see the PWL measurements only consists of the phase observations rather affected by the range. So the PWL noise is much lower than the MW measurement. As we can see, if we can determine the actual white line in advance, the white line in the equation can be extracted and fixed easier. Based on the above normal manners, we derive our multi-frequency clock estimation model. First, we have dual frequency baseline LC like this, and then we incorporated the phase white lane measurement into the observation model. As for the non-datum frequency code bars, which cannot be assimilated into the receiver clock, so we add another parameters into the function. After establishing the multi-frequency LC, another problem confronts us. That is how to deal with the time variable IFCB in real time. Current research uses GFF combination or network BP or prediction methods. but all of them have their own flaws. Let's recall the phase wavelength measurements we mentioned above. After multi-frequency IFC demonstration, variables in the red box are all known. Therefore, the remaining IFCB in the equations can be extracted naturally. And in this way, the IFCB will be continuous for the sake of the data provided by the UPD. Under multi-frequency conditions, each ambiguity should be corrected by a specific UPD before fixed, which is such inflexible, while using OSB is more compatible. So, obeyed by the IGS settings convention, we convert all of my products to observation-specific bars. We hire China networks to validate our real-time service. At the beginning, we investigate the third frequency contribution to the ambiguities resolutions. These tables summarize the fixed rate for different types of ambiguities whose elevation are below 30 degrees after different smoothing span. When the satellites are just in view, extra white line or phase white line can both reach 95% in 2 minutes, much better than the undirected white line. And meanwhile, the fast resolution of the white line ambiguities can subsequently improve the narrow line fixed rates. As we can see, triple frequency strategy increased the narrow fixed rate by 28% than the dual frequency. Let's take an example for further illustrate. C21 with higher elevation, it requires less time to converge. And meanwhile, the triple frequency in yellow line converges faster than the dual frequency in purple line, which improves the availability of regional real-time clock when the elevation is low. In the terms of the real-time clock's precision, the STD of float clock is relatively lower. When the ambiguities fix into integers, the ILC STD are the comparable precision to the to the rapid product. Of course, what we consider most is the real-time phase OSB. First, the phase OSB estimates by the regional clock exhibits time-variant trend, suggesting the products retrieved by our method contains not only the phase hardware delay, but also the float clock error. Also, the fluctuations of the GPS appears to be pronounced than any other system. That's attributed that not all the GPS satellites transmit the triple frequencies triple frequency signal at present. So the number of the phase white lanes could be fewer. Let's see the right lower corner. The FCB exhibits continuous and cyclic features. Procedures of the float clock directly affected the DP accuracy. Given the stability of OSB in the serials is not sufficient to judge its quality, then we further validate the OSB's compensations for float clock. Well, after introducing the phase OSB product, the mode 2 greatly improves the positioning service. Therefore, our phase OSB can refine the float clocks and correct the phase hardware's delay. Based on the products we generated above, we conducted a real-time PPP validations. We found during the initialization, triple frequency positioning obtains the highest accuracy. After converge, baseline dual frequency shows the compelled final accuracy to triple frequency. As for the convergence performance related to users' experience, we set the convergence criteria to maintain a horizontal accuracy of 5 minutes and a vertical accuracy of 10 minutes, of 10 centimeters for 2 minutes. For beta only, triple frequencies reach nearly 65% convergence within 1 minute. And in the multi-constellation, triple frequency achieves 91% in horizontal instantaneous convergence. In some sense, we built a PPP ability to perform article-like convergence. To conclude, we developed a regional real-time instantaneous PPP service based on a multi-constellation and multi-frequency LC estimator, and utilizing triple frequency observations, multi-constellation PPP instantaneous convergence can reach 91% in horizontal and 84% in vertical. Overall, it can be used as a practical alternative public PPP service for many real-time applications. That's all. Thank you for your attention.